You're standing in the smart home aisle, staring at dozens of devices that all promise seamless integration. The reality? Most people buy 3 different smart locks before finding one that actually works with their security system. That's an expensive education. I'm Marcus Chen, and I spend my days consulting on residential smart home installations. What I've learned is this: smart device comparison isn't about feature lists. It's about understanding protocol compatibility and hub requirements before you tear open the box.
You're listening to the Smart Home Setup Podcast. Quick note before we dive in. Everything you're about to hear, the research, the data, the script, that's all human verified and written by real authors. The voice you're hearing right now, that's AI generated. Just wanted to be upfront about that. If you've been listening for a while, thanks for being here. It genuinely matters. And if you're new to the show, welcome aboard. We release new episodes every Monday, Wednesday, and Friday. Today, we're tackling something that trips up almost every smart home beginner: how to actually compare devices so you don't end up with a drawer full of incompatible gadgets. Let's jump in.
Smart device comparison is the systematic evaluation of smart home products across protocol compatibility, hub requirements, automation capabilities, and ecosystem lock-in before you commit to a purchase. It's not about which device has more features. It's about which device will actually work with what you already own and deliver the automation logic you need. When I say comparison, I'm talking about more than side-by-side spec sheets. You're evaluating whether a Zigbee motion sensor will communicate with your Matter-enabled hub, whether your existing Wi-Fi network can handle another 20 devices without dropping connections, and whether the automation platform you're using supports the conditional logic you want to build. The fundamental comparison framework includes 5 layers. First, protocol evaluation, which covers Zigbee, Z-Wave, Thread, Matter, and Wi-Fi. Second, hub and bridge requirements, basically what hardware you'll need to make it work. Third, ecosystem compatibility with platforms like Google Home, Amazon Alexa, Apple HomeKit, or Home Assistant. Fourth, automation logic capabilities, meaning if-then statements, conditional triggers, and scene support. And fifth, fallback behavior and reliability, what happens when your internet goes down. I've seen homeowners buy 3 different smart locks before finding one that actually integrates with their security system. Smart device comparison prevents that waste by forcing you to validate compatibility before the purchase, not after the return window closes. Now let's talk about how this actually works in practice. The comparison process starts with mapping your existing infrastructure. You can't evaluate a new device in isolation. You need to know what protocols your current hub supports, what automation platform you're running, and whether your network can handle the additional load. First step, document your current protocol ecosystem. Start by listing every hub, bridge, and controller you already own. Each one supports specific protocols, and that determines which devices you can add without buying additional hardware. Here are the common hub configurations I encounter most often. An Amazon Echo, 4th generation or later, supports Zigbee 3.0 natively, Matter 1.4 with firmware updates, and Thread via border router functionality. A Google Nest Hub 2nd generation supports Thread and Matter 1.4, but it requires a separate bridge for Zigbee or Z-Wave. An Apple HomePod Mini supports Thread and Matter 1.4, but there's no Zigbee or Z-Wave support at all. Home Assistant with Zigbee and Z-Wave dongles supports all protocols depending on which USB adapters you've installed. And a Samsung SmartThings Hub version 3 supports Zigbee 3.0, Z-Wave Plus, and Matter 1.4, but no Thread without an additional border router.
If you're running a Google Nest Hub versus Amazon Echo versus Apple HomePod setup, your protocol support varies dramatically. An Echo owner can add Zigbee devices directly, while a HomePod owner needs a separate Zigbee bridge like the Philips Hue bridge. Second step, evaluate protocol-specific trade-offs. Each protocol comes with distinct latency, range, and reliability characteristics. When you're doing a smart device comparison, you're not just checking whether a device uses Zigbee or Wi-Fi. You're evaluating whether that protocol fits your use case. Let me walk through the characteristics of each major protocol. Zigbee 3.0 uses a mesh network topology where each powered device extends range. Typical latency is 30 to 100 milliseconds for local commands. Range is about 10 to 20 meters per hop with a self-healing mesh. Reliability is high for lighting and sensors, but you need at least 3 to 5 powered devices for a stable mesh. For fallback behavior, the local mesh continues operating if internet fails, but cloud-dependent hubs lose control. Z-Wave Plus also uses mesh network topology, but only AC-powered devices participate in the mesh. Typical latency is 40 to 120 milliseconds for local commands. Range is 30 to 40 meters per hop, and it's less congested than 2.4 GHz protocols. Reliability is excellent for locks and garage doors due to interference immunity. The local mesh persists during internet outages, but most hubs require internet for the control interface. Matter 1.4 is a unified application layer over IP that runs on Thread, Wi-Fi, or Ethernet. Typical latency is 50 to 150 milliseconds, depending on the underlying transport. Range varies by transport. Thread mesh is about 10 to 30 meters per hop. Wi-Fi is router dependent. Reliability is still maturing in 2026. Some devices have inconsistent controller synchronization. Local control is supported when implemented correctly, but it requires hub firmware to prioritize local execution. Wi-Fi uses a star topology where all devices connect directly to your router or access points. Typical latency is 100 to 300 milliseconds due to cloud round trips for most consumer devices. Range is 10 to 30 meters from the access point, limited by your router's capability. Reliability is vulnerable to network congestion, DHCP lease issues, and ISP outages. Most devices become completely non-functional when internet fails. When you're comparing a Zigbee motion sensor versus a Z-Wave motion sensor, latency matters if you're triggering security actions. I typically see Zigbee sensors respond 20 to 40 milliseconds faster than Z-Wave in identical network conditions, but Z-Wave offers superior interference immunity in dense apartment buildings. Third step, map hub requirements and ecosystem lock-in. Smart device comparison gets complicated when you realize most devices require platform-specific hubs or bridges, and not all of them play nicely with multi-protocol setups.
Here's the hub requirements checklist I use on every installation. Does the device require a proprietary bridge? Philips Hue, IKEA Trodfree, and Lutron Caseta all require dedicated hubs, even though they use open protocols. Can my existing hub adopt this device directly? Check firmware version. Many hubs added Matter support in 2025 to 2026 updates. Will adding this device create a secondary control interface? Managing lights through 3 different apps is a usability nightmare. Does the device support local control, or is cloud connectivity mandatory? This affects reliability and privacy. And what happens if the manufacturer shuts down their cloud service? Proprietary Wi-Fi devices often become useless. Look at what happened with Insteon. I've worked with homeowners who owned 4 different hubs because they didn't understand hub requirements before buying devices. The Lutron Caseta system requires its proprietary bridge, even though it's technically a variant of the ClearConnect RF protocol. Philips Hue requires its bridge for full functionality, even though the bulbs are standard Zigbee 3.0 devices. Matter 1.4 was supposed to solve this, but in practice, you still need to verify Matter hub requirements carefully.
Some Matter devices work across ecosystems flawlessly, while others exhibit quirks like delayed state synchronization or missing features when controlled from non-native platforms. Fourth step, test automation logic capabilities. This is where smart device comparison becomes technical. You need to verify that your automation platform supports the logic you want to build before buying devices that promise advanced triggers. Let me give you some examples of common automation logic patterns and which platforms support them. The simplest pattern is if-then with a single condition. If motion is detected in the hallway, then turn on hallway lights to 50% brightness. This is supported by all major platforms: Google Home, Alexa, HomeKit, Home Assistant, and SmartThings. A more complex pattern is if-then with multiple and conditions. If motion is detected in the hallway, and the time is between 10 p.m. and 6 a.m., and the luminance sensor reads below 10 lux, then turn on hallway lights to 30% brightness. This is supported by Home Assistant and SmartThings. SmartThings has limited support with complex workarounds. Alexa and Google Home require multiple routines. Apple HomeKit doesn't support this natively.
Then there's state-based logic with timers. If motion is detected in the bathroom, turn on the exhaust fan. Wait 15 minutes after motion stops, then turn off the exhaust fan. This is supported by Home Assistant, Habitat, and SmartThings. Alexa has limited support with fixed timer durations only. Google Home and Apple HomeKit don't support this natively. When you're doing a smart device comparison for security applications, you need platforms that support complex conditional logic. I walked one homeowner through creating energy-saving automations with Home Assistant specifically because Google Home couldn't handle the multi-condition logic she needed for her HVAC scheduling. Fifth step, verify latency, reliability, and fallback behavior. The final comparison layer involves testing response times and understanding what happens when things fail. Marketing materials never mention that your so-called instant smart lights might take 2 to 3 seconds to respond during peak Wi-Fi congestion. Here are the latency expectations I've measured across protocols. A Zigbee motion sensor to a Zigbee bulb on the same mesh takes 30 to 80 milliseconds. A Z-Wave sensor to a Z-Wave switch on the same mesh takes 40 to 100 milliseconds. A Wi-Fi sensor to a Wi-Fi bulb, both cloud-dependent, takes 200 to 800 milliseconds, depending on server load. A Matter device to a Matter controller using thread transport takes 50 to 150 milliseconds. A Matter device to a Matter controller using Wi-Fi transport takes 100 to 400 milliseconds. And cross-protocol automation, like a Zigbee sensor to hub to Wi-Fi bulb, takes 150 to 500 milliseconds. If you're comparing Matter smart lights versus Wi-Fi smart lights, the latency difference becomes obvious in fast response scenarios, like motion-triggered security lighting. I've seen Wi-Fi bulbs lag so badly that the homeowner walks through the entire room before the lights turn on. Fallback behavior is the reliability test most people skip. Unplug your internet router and see what still works. In my installations, I aim for these fallback standards. Security devices like locks, cameras, and motion sensors must function locally without internet. Critical lighting in entryways and staircases should default to manual control if automation fails. HVAC and energy management should maintain the last programmed schedule during internet outages. Non-critical devices like accent lighting and voice assistants can fail gracefully. The smart device fallback behavior checklist I use includes testing internet disconnection, hub power loss, and individual device network drops. Devices that become completely non-functional during temporary Wi-Fi glitches don't make it into my recommendations. Moving on to why this matters for your home. You're not just buying a smart bulb, you're buying into an ecosystem that determines which future devices you can add, which automation logic you can build, and whether your setup will still work in 5 years.
I've consulted on installations where homeowners spent $3,000 to $5,000 on smart devices, only to discover they'd locked themselves into an ecosystem that couldn't support the automations they actually wanted. One client bought 30 GoV Wi-Fi smart lights because they were inexpensive, then realized they couldn't create the motion-triggered lighting scenes they envisioned because GoV's automation platform only supports time-based triggers. The real cost of poor device comparison includes several things. Duplicate hub purchases waste $50 to $150 when you buy a Zigbee hub, even though you already own a Matter-capable border router. Non-interoperable devices create problems. Owning smart locks that can't trigger your smart lights requires expensive workarounds or hub consolidation. Cloud dependency vulnerability means building your entire home automation on Wi-Fi devices so everything stops working during internet outages. And platform migration nightmares make it exponentially harder to migrate to Matter 1.4 when you've invested in proprietary protocols. In the Pacific Northwest, where I do most of my work, we have frequent winter power outages. Homeowners who built their systems on cloud-dependent Wi-Fi devices discover that none of their automations work when the internet goes down, even though their local power is back up. Those who built on Zigbee or Z-Wave mesh networks maintain local control through their hub's battery backup. The Smart Home Protocol Compatibility Guide I reference constantly shows that protocol choice affects your home's reliability for years. You can't easily swap protocols after you've installed 40 devices. You're committed to that ecosystem. Now let's look at the types of comparisons you'll encounter. Smart device comparison isn't a single process. It varies based on device category and your existing infrastructure. Here are the comparison frameworks I use most frequently in residential installations. First, protocol-to-protocol comparison. When you're choosing between devices that use different protocols, you're comparing the underlying communication standards before you even look at device features. Let me give you an example. Zigbee plug versus Z-Wave plug. The comparison reveals that both protocols work well for plug automation, but Zigbee offers faster response times, typically 30 to 50 milliseconds faster, while Z-Wave provides better interference immunity in congested RF environments. If you live in an apartment building with dozens of overlapping Wi-Fi networks, Z-Wave's 900 MHz frequency avoids the 2.4 GHz congestion that affects Zigbee.
When should you choose Zigbee? When you already own a Zigbee hub like an Amazon Echo, Samsung SmartThings, or Home Assistant with a Zigbee dongle. When you need fast response times for lighting automation. When you're building a large mesh network. Zigbee handles 65,000 plus devices theoretically, hundreds practically. And when you want the widest device selection, since Zigbee has more manufacturers and product variety. When should you choose Z-Wave? When you live in an RF congested environment like apartments or dense neighborhoods. When you're prioritizing security devices like locks and garage doors that benefit from interference immunity. When you need reliable long-range communication, since Z-Wave's lower frequency penetrates walls better. And when you want guaranteed interoperability because Z-Wave certification is stricter than Zigbee. Second, feature-to-feature comparison within the same protocol. Once you've settled on a protocol, you're comparing specific device capabilities and manufacturer implementations. This is where most people start and where they often make mistakes by ignoring protocol fundamentals. Example, Philips Hue versus Lutron Cassetta for smart lighting. Both systems offer excellent lighting control, but they serve different use cases. Philips Hue excels at color-changing accent lighting and entertainment sync features. It requires the Hue Bridge hub. It uses Zigbee protocol but with proprietary extensions, and it offers bulb-level control, so you can replace bulbs without rewiring. Lutron Cassetta focuses on whole-room dimming and switching with rock-solid reliability. It requires the Lutron Bridge. It uses Lutron's proprietary Clear Connect RF protocol, and it requires professional-grade installation because it replaces wall switches, not bulbs. The comparison comes down to use case. Hue for color lighting and entertainment, Caseta for reliable whole home lighting control. I've seen homeowners buy Hue thinking it'll replace all their lighting, then discover they need $20 to $40 per bulb across 50 sockets. That's $1,000 to $2,000 versus $300 to $600 for Caseta switches that control existing bulbs. Third, ecosystem to ecosystem comparison. This comparison layer evaluates how well devices work within specific control platforms like Google Home, Amazon Alexa, Apple HomeKit, or Home Assistant. Example, Matter 1.4 device controlled through Google Home versus Amazon Alexa. Matter promised perfect interoperability, but real-world implementation reveals quirks. Google Home tends to sync Matter device states faster. I measured a 50 to 100 milliseconds advantage in my testing, but it offers limited conditional automation logic. Amazon Alexa provides more complex routine building. It supports temperature triggers and door sensor logic, but it occasionally exhibits delayed state updates with Matter devices from certain manufacturers.
Apple HomeKit offers the strongest privacy protection and local execution, but it has the most restrictive automation logic. No OR conditions, limited sensor types. I've had clients switch from Google Home to Home Assistant specifically because Google's automation platform couldn't support the energy-saving automations they wanted to build. The devices were Matter compatible and worked fine. The limitation was the ecosystem's logic engine. Let me answer some frequently asked questions. What protocol should I choose for my first smart home devices? Matter 1.4 over Thread is your best starting point in 2026 because it offers cross-ecosystem compatibility and mesh network benefits without locking you into a single manufacturer. Start with a Matter-compatible hub like an Amazon Echo 4th generation or later, Apple HomePod Mini, or Google Nest Hub 2nd generation. Then add Matter-compatible devices gradually. If your hub doesn't support Thread yet, which powers most Matter devices, add a Thread border router. Many hubs received this via firmware updates in 2025. Avoid starting with proprietary Wi-Fi devices that depend on manufacturer cloud services. These create vendor lock-in and single points of failure. You can always add Zigbee or Z-Wave devices later through additional hub hardware, but Matter gives you the widest ecosystem flexibility from day one. How do I compare smart devices if I already own a mix of protocols? Map your current ecosystem first using the protocol documentation method. List every hub, bridge, and controller you own. Note which protocols each supports. Then identify which automation platform ties them together: Home Assistant, SmartThings, Alexa, or Google Home. When evaluating new devices, check whether they connect to your existing hubs without requiring additional bridges. For example, if you own an Amazon Echo 4th generation, you can add Zigbee devices directly, but need a separate bridge for Z-Wave devices. I recommend using Home Assistant as a unified control layer when you're running multiple protocols. It supports Zigbee, Z-Wave, Matter, Thread, and Wi-Fi simultaneously through various integration methods. The key comparison factor becomes, does this device reduce my hub count or increase it? Every additional bridge adds complexity, potential failure points, and interface fragmentation that makes your system harder to manage. What latency is acceptable for different smart home automation types? Latency requirements vary dramatically by use case, and understanding these thresholds helps you compare device protocols effectively. For motion-triggered security lighting, aim for under 200 milliseconds total response time. Anything slower feels laggy when you walk into a dark room. For HVAC automation and energy management, 1 to 2 second delays are perfectly acceptable since temperature changes happen gradually anyway. For voice-activated commands, users tolerate up to 1 second of latency before the experience feels broken. For entertainment synchronization, like lighting that matches TV content, you need under 100 milliseconds or the effect looks obviously delayed.
I measure latency across the entire automation chain: sensor detection, plus hub processing, plus command transmission, plus device response. A Zigbee motion sensor to Zigbee bulb running locally through a good hub typically achieves 50 to 150 milliseconds total latency, while a Wi-Fi sensor to cloud-dependent Wi-Fi bulb might take 500 to 1500 milliseconds because the command loops through internet servers. How do I test whether smart devices will work together before buying them? Use the 3-layer compatibility verification method I apply on every installation. First, confirm protocol compatibility by checking whether your existing hub explicitly supports the device's protocol, not just works with marketing language, but actual technical specs confirming Zigbee 3.0, Z-Wave Plus, Matter 1.4, or Thread support. Second, verify ecosystem compatibility by searching your automation platform's device integration database. Home Assistant publishes a comprehensive integration list. Alexa and Google Home maintain compatibility lists on their developer sites. Third, test automation logic by building a mock routine in your platform. Create the if-then statement you want without the physical device present and verify your platform actually supports that trigger action combination. I've seen countless cases where devices technically worked but couldn't trigger the specific automation the homeowner wanted because the platform didn't support that sensor type as a conditional trigger. Check community forums for real-world compatibility reports. Reddit's home automation and home assistant communities surface integration issues manufacturers don't advertise. Should I prioritize local control or cloud features when comparing smart devices? Prioritize local control for any device that affects security, safety, or critical infrastructure. Then layer cloud features on top as convenience additions rather than dependencies. Your smart locks, security cameras, motion sensors, smoke detectors, and primary lighting should all function without internet connectivity. This means choosing devices that support local execution through your hub's automation engine or operate via mesh protocols like Zigbee, Z-Wave, or Thread. I've responded to emergency calls where homeowners couldn't unlock their cloud-dependent smart locks during an internet outage. Their physical keys were inside the house and the lock was completely non-functional. For less critical devices like accent lighting, voice assistance, or entertainment integration, cloud dependency is acceptable because failure doesn't create safety issues.
When comparing devices, specifically ask, what happens when my internet goes down? And test this scenario during your return window. The principle applies across all device categories. Internet connectivity should enhance functionality, not enable basic operation. Let me wrap this up with some key takeaways. Smart device comparison requires you to evaluate protocol compatibility, hub requirements, automation logic support, and reliability characteristics before you commit to a purchase. You're not comparing feature lists. You're validating whether the device will actually integrate with your existing infrastructure and deliver the automation behavior you expect. The comparison framework I use on residential installations starts with protocol evaluation: Zigbee, Z-Wave, Thread, Matter, Wi-Fi. It maps hub requirements to prevent unnecessary bridge purchases. It verifies ecosystem compatibility with your automation platform. It tests the specific automation logic you want to build, and it measures latency and fallback behavior in real-world scenarios. Every device you add shapes your ecosystem's future expandability. Choose protocols that support mesh networking for reliability, prioritize local control for critical functions, and verify that your automation platform can actually process the conditional logic you're envisioning. Test during your return window. Build the automations you actually want. Unplug your internet and verify fallback behavior. That's how you validate compatibility before you're stuck with devices that don't deliver the integration you expected. That wraps up today's episode of the Smart Home Setup Podcast. We'll be back with a new episode every Monday, Wednesday, and Friday. If you got something out of this one, I'd really appreciate it if you left a 5-star rating and a quick review. It genuinely helps other people find the show when they're searching for smart home advice. And make sure you're subscribed or following so you get notified the second a new episode drops. Thanks for listening.